Okay. Okay. Let's see, we got everybody there. Yes, good. So welcome to Dale Partin's portion of our little program here. Little introductions. Dr. Dale Partin, did a career in industrial physics with 38 US patents and over 80 science publications. And he now teaches astronomy at Macomb Community College, and he's vice president of the Warren Astronomical Society, which is one of our GLAAC member societies. And he's the guy who arranges all the speakers for their program. He enjoys being out under the skies at night with his telescope observing. Don't we all? And his topic tonight is going to be Mars, past, present, and future. Dale, it is a pleasure to finally be here. Apologies to everyone online for being a pinch late, but we are only 4 minutes late, which is much better than our previous one. So with that, I'm going to let you take it away.
Okay, thank you, Jeff.
And I'm going to monitor from outside by my telescope, and we'll look for questions and get things going from there.
Okay, thank you.
Okay, head two.
All right, so the topic, Mars, past, present, and future. I showed two pictures of Mars here. How Mars, we think, looked about 4 billion years ago, when it was a warm, wet planet with an ocean covering its northern hemisphere and a thick atmosphere. And we don't know whether there were living things there or not. On the right is how Mars looks today. It's a cold desert with very little atmosphere left. It does have two polar caps, partly of water ice, like our polar caps, and a lot of carbon dioxide frozen as what we call dry ice. That's what Mars is like today. Why did the Earth wind up being a warm, wet place today and not Mars? There are two factors which mostly determine that. Mars is smaller than the Earth. The ratio you see here is about correct. And it's farther from the sun. So Mars cooled off faster. Both planets initially were molten balls of rock and metal. The metal settled into the core, mostly iron. The rock became the mantle with a thin layer of crust on the top. But Mars, being smaller, the heat didn't have as far to go to get out to the surface and radiate away. So it cooled faster and became very cold. It's also smaller, indicating a lower amount of surface gravity, about 38% of Earth's gravity on its surface. Because it has less gravity, it couldn't hold down an atmosphere very well like the Earth, and it lost almost all of it. The atmospheric pressure on the surface of Mars today is about 38% of Earth's, is about 1% of Earth's atmospheric pressure. Because it lost its atmosphere, it's all the water on the surface boiled away or evaporated. So it lost its oceans and its rivers, although there's still underground water, maybe liquid, it may be frozen, but we can see it from orbit with ground penetrating radar. So we know in some areas of Mars, there's still a lot of water underground. How much, we're still exploring. So some important issues I'm going to talk about this evening are, first and foremost, is there life on Mars? I do not mean intelligent aliens. 50, 100 years ago, some people used to think there might be. there's no evidence of that now. We've got high resolution pictures of the whole planet. There's absolutely nothing on the surface that would indicate that. We've got rovers in a few places trundling around looking at everything. No evidence whatever of anything intelligent. So the real question is there primitive life on Mars? Or if there isn't, was there in the past when Mars was more habitable? So that's one thing I'll talk about. Secondly, what are the issues with getting people to Mars? And then after they get there, what's it like? What will it be like to try to live there? Then do we have to worry about cross-contamination of Earth and Mars with bacteria like organisms, microorganisms? And finally, to what extent can we think of ever terraforming Mars to make it either more like it once was, or even better, more like the Earth is? How difficult would that be? So first, is there, or at least was there, life on Mars? NASA's had a series of rovers on Mars. The only one left working right now is the NASA Curiosity rover. It's been there for about 9 years with a lot of scientific equipment on board. That equipment is not optimized for looking for life. It's the question that equipment was designed to answer is, was Mars ever a habitable place where living things could exist, at least as we know them here on Earth? And we have a very clear answer to that. The answer is yes. Mars was once a warm, wet world with a fairly thick atmosphere, the right surface chemistry to support life. Whether there ever was or still is life there is unknown. Just a month ago, NASA launched another rover. It looks kind of like the Curiosity rover. It's called Perseverance. It's on its way to Mars now. It'll get there in February. It has equipment more oriented toward looking not for living things exactly, but for evidence of living things like complex organic compounds. My main regrets about this rover are it did not take equipment to specifically test for living things, culture them or something like that. And secondly, the drill it has can only go down, I think 4 centimeters, maybe it's 4 inches, I forget, but not very deep. I think it would have been helpful to go deeper. There are 2 other spacecraft on the way to Mars right now, a combination Japanese-Indian spacecraft that'll just orbit Mars, and a Chinese spacecraft that will have a lander with a rover. The Europeans tried to send one, but didn't make it, so they have to wait a while to send it. In the future, the plan, I'm sure, is to send scientists to Mars with lots of advanced analytical equipment, and we will find out for sure by that, if not sooner with these rovers, whether there is or was life on Mars. One way or another, we will see. So, getting people to Mars. Right now, if you were a billionaire, not many of us are, and you said, I want to buy a ticket to Mars, a round trip ticket, let's say, nobody can get you there and back, even for $1 billion, even for $10 billion. There's no spacecraft that can do that. The company that's trying the hardest, and they're trying hard to develop such a spacecraft, is called SpaceX. They have a spacecraft that the plan for it is to go to Mars and back with people. They're making it reusable so it can make multiple trips and get the cost down. And they're switching from kerosene as a fuel with oxygen to methane, because even though kerosene in some respects is a more energetic fuel, you can't manufacture kerosene on Mars, but you can start with underground water on Mars and carbon dioxide in the atmosphere. And there's a chemical process you can do to manufacture methane fuel and oxygen to burn the fuel and to breathe out of those things. So it really helps that we don't have to take all the oxygen and methane fuel that we need to Mars in order to fly back. So stay tuned. That rocket is in development. It's worth mentioning that you can't take off with a spacecraft anytime you feel like it to go to Mars. Earth and Mars only align with each other in an appropriate way to launch every 26 months. Here we have the Earth. I hope you can see my cursor. Here's Mars. We just went through that launch window a month ago, and as I mentioned, 3 spacecraft are on their way to Mars. The NASA spacecraft will arrive in mid-February. The Europeans missed, slowed down by COVID, I think. So they have to wait 26 months before they can launch their rover. So on the way to Mars, people will be weightless. This can be kind of fun up to a point. This is an aircraft where they take people up to high altitude and then turn off the engines so the plane sort of coasts or falls through the air. If you're at high altitude when you do this, but there's very little air resistance, so you're close to being weightless inside for maybe 4 or 5 minutes. And so that can be kind of fun. Nobody throws up because of weightlessness that fast. If they're up there for a couple of hours, some of them would probably do that until they got used to weightlessness. But it's fun for a little while. But after you've spent 6 months on the International Space Station, being weightless is not always so fun. Your muscles atrophy and your bones lose a lot of their density, so much so that astronauts, if they've been up there for 6 months, really can't walk. They might be able to stagger a little bit, so they're carried after they land. I noticed the 2 astronauts, the 2 US astronauts that SpaceX just put up to the ISS, walked when they got back, but they'd only been up there for 2 months. And by the way, all astronauts on the ISS spend 2 to 3 hours every day doing vigorous exercises. But our bodies are just optimized for 1G of gravity, not 0G. There are other health effects of long-term weightlessness. I have a list of them here. One of the problems is your heart and circulatory system pushes blood up into your head harder than it otherwise would, because it's pushing against gravity if you're sitting up or standing up. When you get up into space, your heart and arteries and so forth don't know to stop doing that. So they overpressurize your head, putting pressure on the backs of your eyes and deforming them so that it changes, for some astronauts, it changes their vision. So now you see an astronaut here doing periodic measurements on her eyes to see if she's going to need glasses. And there are other issues. There are various approaches to fixing that. In traveling to and from Mars, one sort of physics-oriented fix is to attach 2 spacecraft together, nose to nose, and spin them. So you create artificial gravity via centrifugal force. If this is done, it solves the problem of coasting to and from Mars. It's not so simple as it might look to make this happen. We will see if SpaceX and others actually do this. I've seen nothing that tells me they plan to, but this would be a guaranteed fix if it's done. Even if we did that, once you get to Mars, you have to stay there for about 2 years until the planets align to come back. So, you know, the gravity is not 0 G on Mars, but it's only 38% of Earth's gravity. So we don't know if people can naturally adapt to Martian gravity. It's sure better than 0 G, but I think the jury is out, but doubtful that we can adapt to that low of a gravity. One fix to that is to spend part of every day in a centrifuge. Not my idea of what I want to do on Mars. There are some drugs I just read about in early development. It's sort of become known which genes are responsible for causing muscle atrophy and bone loss, bone density loss, and so forth. And experiments have just been, a first round of experiments have just been done on mice where they succeeded in turning off the genes that cause those problems. There's a long way to go on that, but there's hope. The ultimate solution for people that plan to stay for the rest of their lives on Mars is to genetically re-engineer them to optimize them for Martian gravity instead of Earth gravity. Problem is, once you do that, you can't come back to Earth because it would just feel like crushing gravity then, unless you re-engineer them. I mean, how hard this will be, I don't know. I think it's going to take some time, but genetic engineering is advancing fast. So it'd be better if we could just use some drugs that would temporarily turn off problem genes, hopefully without negative side effects. We will see. Stay tuned. The other serious health issue concerns radiation exposure. With a 3-year round trip to Mars, according to some estimates, 5% of astronauts may eventually die as a result of radiation. So we really need to shield the astronauts from that, both en route to and from Mars and on Mars. To a large extent, that is doable. The two sources of radiation that matter here are the solar wind, consisting mostly of protons, and cosmic rays, which are mostly protons, coming from distant galaxies for the most part. The solar wind particles get excited up to 1,000,000 electron volt kinds of energies, which can penetrate the spacecraft hull and do damage, especially during a solar storm when they could be lethal within hours. Fortunately, at the energy level of those particles, they can be essentially completely shielded. So we have to do that, and the plan is to do that. At least I know SpaceX is planning for a shelter from solar storms, a shield people can get behind for a few hours. Cosmic rays are a different problem. They're mostly at higher energies, giga electron volts and even up. The lower energy ones can be shielded. The high energy ones cannot. So we need to do the best we can. And surprisingly to a lot of people who have this romantic idea of living on Mars and living in a little flimsy habitat on Mars, like the Martian in the movie, just a plastic thing. Once on Mars, people are going to have to stay mostly underground for protection from cosmic rays. Fine to go up on the surface in a spacesuit for a few hours or something like that, here and there, but mostly underground. Just to give you a sense of cosmic rays, I have here a Geiger counter that I got through Amazon. Let me turn it on. You hear some clicks. Those are cosmic rays coming from distant galaxies all the way down through the Earth's magnetic field, all the way through the Earth's atmosphere, through the ceiling of my house, and into a little detector in this thing. I carried this on an aircraft with me. I was in Austin, Texas, and they let me through security with it, somewhat to my surprise. And I kept it running during the flight back to Detroit Metro. We flew to Chicago and then from there to Detroit. And you can see the count rate here. I had it set up to average every 10 minutes. The count rate when we were going from Austin to Chicago went up 25 times. And that was just at 33,000 feet. I only know the altitude because the pilot mentioned it over the intercom. But that's a fairly typical cruising altitude. It gets worse the higher you go. At the top of the Earth's atmosphere, where the ISS is just above that, the count rate is, I think, about 160 times what it is here on the surface. Once you're well away from the Earth and its magnetic field on your way to Mars, it's something like 1,000 times higher count rate. There have been statistical studies of airline flight crews that I've read about that suggest they have a slightly elevated rate of cancer. But multiply their exposure, not by 8 hours a day or whatever it is at high altitude, but 24/7 in space, far from the Earth where the count rate is higher, away from the Earth's magnetic field and atmosphere. So it's a serious issue. I'm going to shut this off. So, that's probably the toughest issue to deal with right now for going to Mars. So much for going to Mars. What about living on Mars? Raw Mars is lethal. If you land on Mars and you open the door on your spacecraft without a spacesuit on, you'll be dead within some seconds. The atmosphere is thin, about 1% of our atmospheric pressure, and it's mostly carbon dioxide. It's basically an unbreathable atmosphere. So you have to wear a spacesuit if you're out on the surface. The temperatures most of the time are freezing, especially at night. So I show a possible Martian habitat in the upper right picture. Either natural caves or lava tubes could be adapted to underground habitats, pressurized with warm air, and protected from cosmic rays. If you're, say, 30 feet under the surface, you're protected. Not that a few cosmic rays can't make it through, but you'd need a mile of rock to stop the most energetic ones. And you don't need to. So we'd be living mostly underground. We'd have to deal with low gravity, Martian gravity. I've talked about that. Cosmic rays. You could go up on the surface, as I think I mentioned, for maybe 2 or 3 hours a day if you need to. But then you need to get back under the ground. There's no water on the surface. I show a picture on the lower right of an ancient river on Mars seen from orbit where the water all dried up. What's left is underground, imaged with ground penetrating radar. So we know where it is, but we don't know exactly how much there is and how deep it is yet. And there's no Martian food. You can't walk outside and pick an apple, not even crab apples, right? I mean, you're gonna have to grow everything underground. The soil has some toxic chemicals in it, most especially something called perchlorate compounds that are sort of chemically similar to bleach. Fortunately, you can get them out of the soil if you need soil to grow plants in by just rinsing water through the soil. The perchlorate compounds are very water soluble. There's even a paper published in a chemistry journal on how to take those perchlorate compounds and use them to make oxygen for breathing. So those are the issues one has to deal with. Having worked in industry, you sort of learn that challenges, problems are not showstoppers, they're challenges to be overcome. I don't see anything here that cannot be overcome. Not that it'll be easy. How do we get electrical power on Mars? One solution is to use solar cells. Mars is farther from the Earth, so you only get about half as much sunlight, but that's enough. You could get plenty of electrical power using solar cells until there's a dust storm. These seem to come along every year or 2 or 3 years. And even though the atmosphere is very thin, so it doesn't push on dust very hard, there's a lot of dust on Mars that's so fine that even Martian air is thick enough to get them stirred up and basically block sunlight. This is a picture taken of the sun every day as a dust storm was coming from a NASA rover. And you can see after a few days, you cannot even see the sun. This is not too good for if you're totally dependent on solar cells to get electrical power. Excuse me. So there are 2 solutions to this. The high-tech one is one that NASA is developing, small nuclear reactors. So you'd use multiple of these to get however much power you needed. Designed for safety and stability and so forth, I'm sure. The low-tech approach is you'll be generating natural gas, methane, and oxygen using Martian materials, so you can use those chemicals in a natural gas generator to make electricity. Okay, so that's another way to do it. We'll be growing food underground in a controlled environment. That's just obviously the way to do it. So what about cross-contamination of the planets? Let's first talk about contaminating Mars with Earth life. human residents on Mars will contaminate the local area. This is a given. We can try to sterilize the rovers that we put down and so forth as best we can. But once you put people on the ground, boots on the ground, there will be contamination. Microorganisms will spread across the surface rather slowly, partly because the soil has these bleach-like compounds in it, and because there's no ozone layer in the high up Martian atmosphere to absorb ultraviolet light from the sun. So it'll be very intense. Martian spacesuits will have a layer to block out UV light, just like they do on the ISS or when we send people to the moon. But if microorganisms are spreading across the surface, that's a standard way to kill them, ultraviolet light. And there's no surface water to help them survive on the surface. And residual amounts of microorganisms from spacecraft landing on Mars may have already contaminated Mars. The real issue here is we want to minimize the contamination until we can study Martian life if it's there. Just so if we find some microorganisms, they didn't come from us or with us to Mars. I think that can be done. So that's, and it's possible that major asteroid strikes in the Earth's history, I would say it's likely that they threw stuff up faster than escape velocity from the Earth. And so pieces of the Earth may have already landed on Mars. What about bringing back Martian pathogens to Earth with astronauts? That could potentially kill us all. I guess my answer is, if that was going to happen, it would have already happened. There are people that collect meteorites all over the place, especially Antarctica. They're sort of easy to find there because everything is white unless it fell out of the sky. Over 150 meteorites have been found that for sure came from Mars. I don't have the time to go into how we know that, but we know that. That's a lot, considering that's just what we found. One such meteorite that was heavily studied, part of it was never heated above 40 degrees Celsius or 104 Fahrenheit. That's been scientifically established. So if there was life on it, it wouldn't have been killed by such a temperature. It's been estimated that 0.5 ton of Martian rocks fall on the Earth every year. So again, if microbial life from Mars is going to kill us, I think it already would have. So I now like to talk about what I see farther in the future. I talked about Martian habitats being underground in the short term. I think in the medium term, for the next couple of centuries, let's say, life is going to stay underground, and probably even longer than that. That's because we get good protection from cosmic rays. We can control the temperature, the atmosphere, the humidity, whatever. We can have an artificial sun move across the sky, quote unquote, the sky. We can have pipes carrying water that will cause rain to fall. And for the first time in human history, weather forecasting will be perfect. unless we choose to throw in a random rainfall now and then just to keep life interesting. This picture that you see is curved because it's out of a science fiction story about building a colony inside a rotating asteroid. So on Mars, this would be flat. So we would have underground cities, medium term. The harder question to ask is longer term, can we move up to the surface? Can we terraform not just a large area underground, but the whole Martian surface? This is a real challenge. Some of the issues to solve, I mean, the picture you see is from SpaceX showing Mars as it is today on the left and moving through a series of stages. Elon Musk has referred to Mars as a fixer-upper planet. So what are the issues we would need to deal with? First, a thicker atmosphere. Secondly, if possible, make that atmosphere be breathable. Thirdly, throw some greenhouse gases into the atmosphere to warm up Mars. We don't want to do that on Earth, but we want to warm up Mars. A thicker atmosphere would start to give us protection from cosmic rays on the surface. Then a final issue would be toxicity of the soil. I think we're talking about at least 1,000 years to do this, if it can be done at all. Okay, I'm going to discuss 3 possible ways to at least address some of these issues. The first is steer comets into Mars. We know how to do this in principle, and we would eventually, over the next century or two, have the capability to do it. Comets have been referred to as dirty snowballs. They have lots of water and other materials, frozen gases. We would make sure they hit Mars in an uninhabited area and deliver atmospheric gases and water to the Martian surface. To the extent that some of those gases are greenhouse gases, it would help warm the planet and give protection from cosmic rays. Problem I see with this, which I've heard elsewhere, this approach, the problem is debris would be thrown way up high outside the Martian atmosphere, and some of it would continue to rain down onto the planet for who knows how many years, making the surface a dangerous place to be beyond what it already is. I think that's a pretty serious problem. I also calculated how much water you'd likely get out of a good-sized comet. And if you spread it over the whole surface, you're talking about millimeters, which is significant. It would all wind up in the Martian atmosphere, probably, or frozen at the poles. But it's not like one comet's going to do the job. Second approach is build greenhouse gas factories on the surface of Mars. Manufacture a Martian atmosphere. My comment is, to some extent, we've been unintentionally doing this on Earth for centuries with billions of people burning fossil fuels. And we're sort of just, after centuries and billions of people, just starting to have a detectable, measurable effect on the Earth. How long will it take for maybe 1 million people on Mars, say, to significantly affect Mars? It's sure going to take a long time if it's doable. Another approach is to put a ring-like reflector in orbit around Mars, or perhaps in its L1 or L2 point, Lagrangian L1, Lagrangian L2 point, if you know what that is, so that we can reflect sunlight onto Mars that would otherwise have missed Mars. Constructing this gigantic mirror in space. We could perhaps use materials from the two Martian moons, Phobos and Deimos, to get most of what we needed to build that mirror. I'd have to say this would be the largest construction project in human history. Not to say it cannot be done. There are other approaches, but those are some, and I cover them to illustrate that this is going to be a long-term project. A few other issues: price, cost is going to be large. Private industry is best at getting the cost down. Hence, organizations like Blue Origin and SpaceX are making hopefully a better project than NASA would have done. And wealthy tourists will help pay the costs. There's this Japanese guy who's paying an undisclosed amount of money to SpaceX to take him on a trip around the moon, for example, to pick a really expensive trip. I see that as a good thing, because let these wealthy people spend their money this way, helping develop this whole technology. What government will a Mars settlement have once it has a lot of people and becomes self-sufficient, if that should happen? We need to do a lot of work on life support equipment, recycling, living off the land, and dealing with low gravity. High risks to personnel will have to be accepted, and some people are going to die, just like some people that tried to fly across the Atlantic Ocean or sail to India from Europe didn't make it. There are permanent research stations on Antarctica. Will Mars bases progress beyond that? Is another question. Right now, going to Mars is for risk takers. Later, it will be a place to go for those who like to be safe, who wants to go to Mars. Thanks for listening. I hope Jeff is around. Hello, Jeff. To help me.
Jeff is around.
Okay.
Haven't had actually too many questions. Harmony Smurf, I'm not sure who that is exactly, says, without a magnetosphere, wouldn't all of the artificial atmosphere and water just blow away again from the solar wind?
Great question. The answer is yes. However, it would take a long time. I mean, Mars still has 1% of Earth's atmosphere after billions of years of that process. So I think if we create a Martian atmosphere on a time scale of 1,000 years, it'll be there for a time scale of more than 1 million years. Okay, next question.
Earlier on, there was a question, and I think Ken Burton may have addressed it, but it says, wouldn't contamination have already occurred with previous missions? Referring to the contamination of the rocks.
Yes, in the sense of contamination from Earth to Mars. The spacecraft is very difficult to perfectly sterilize them. And other countries that have sent spacecraft to Mars may not do as good a job as NASA. So contamination to Mars, I would say, through human activities has likely happened, at least to a small extent.
Do you think that would be anything that would affect, like, I guess, the life on Mars?
No.
Okay.
As you may not have been tuned in for this whole presentation, but the surface of Mars is a very hostile place to Earth-like microorganisms. Intense ultraviolet light, poisonous compounds in the soil, no surface water. So I think that it would be very difficult for your typical Earth organism to survive on the surface of Mars.
Okay. Let's see if we got anything more here. Harmony Smith basically says, cool. That was what, that was a game ender for the terraforming idea, referring to the artificial atmosphere thing. Any other questions while we got it here? And we'll wait for a few seconds.
Okay.
Yeah. Ken Burton came back. Contamination would be at a minimum. Thank you, Ken. I appreciate you filling in sometimes here. Since I got about 5 things going at once. Can't be helped some days. We knew that the early evening was going to be a busy time.
Sure. Look, I think my hope is this. If there is still bacterial life or something like bacterial life on Mars, we don't want to overwhelm it with Earth life before we have a chance to study it. Because if there is Martian life there, number one, that's extremely important in and of itself. Secondly, we want to know, is Martian life sufficiently different from Earth life that we can say it was an independent origin of life? Because if life originated independently on Earth and Mars, then we know life is common in the universe. But if the life on Mars is too close to being like life on Earth, then that suggests a common origin. Either life on Earth came from Mars and we're all Martians, or life on Mars came, one way or the other. If it cross-seeded the two planets, then we don't know. We don't get a data point. If Martian life is real different, we'll learn a lot about life by studying it. So I don't want our imported microorganisms to overwhelm Martian microorganisms. But Martian life is probably going to be deep underground, buried where there's water, so it's protected. So we can always go to another area of Mars and drill and get samples of Martian life if it's there. I'm all for human settlement of Mars. I wish I was young enough that I stood a chance of going someday. Not going to happen, but maybe some of the young people listening in on this will get their chance. We'll see.
Oh, you never know.
You never know. Yeah, that's right.
It would be lovely if somebody says, wow, astronomy at the beach, that got me all fired up. Ken Burton says, Dale is my hero. And Harmony Smith says, thanks for the show.
Okay, my pleasure. Incidentally, when you clicked on to watch this presentation, at some point on the page you clicked on, there were other things you could click on that show other presentations I've given in the past to the Warren Astronomical Society on a variety of topics, including the search for extraterrestrial intelligence, the origin of the chemical elements. I gave a 3-part series of presentations on the moon. So I would, and other things. So feel free to avail yourselves of that if you're interested.
And And, you know, to, I guess, plug the Astronomy at the Beach thing, all the live sessions are going to be going until midnight. It'd be a good thing to check out Brian Adams. His telescope's down in New Mexico, where they have virtually no smoke and no clouds. It's not hazy, and he's got a marvelous piece of equipment down there too. So that's going on tonight and tomorrow night. And then tomorrow, all the events will start. We'll start again at 3 p.m. with the hydrogen alpha solar stuff with Auni, which was real popular today. And there'll be 2 visuals, solars out there, if, you know, weather permitting, of course, in addition to all of the great speakers and things we have set up for tomorrow. And most of those start, like I say, the solar stuff starts early because the sun goes down early here in Michigan. But most of the stuff starts I think we have one section at 5, and the others all start at 6 o'clock and go till midnight.
And Jeff, just for our audience's information, this presentation and others will be posted on YouTube for the future. So if you like one of them, you can refer friends to see it. Absolutely.
And really, all of the presentations we got here are all going to be on YouTube. We're hoping to get them. Right now, they're all in a bunch of channels, and we're hoping to put together like a general playlist, so it's kind of like one-stop shopping for all of the Astronomy at the Beach stuff. Some technical reasons kept us from putting them all in one big pot, but we'll collect those things and make them available. And as always, the GLAAC website there, the Astronomy at the Beach 2020 website, those links are going to be valid forever. So they're going to keep that site up in perpetuity as well. I said that word again today. I did it wrong for you earlier, didn't I, Dale?
Yeah. Thanks, Jeff, for all that you've done to make this happen.
You're welcome. It's our pleasure. If not a little hair-raising, but it's always a pleasure.
Okay. I guess I'll bid everyone good night.
Okie doke. Thank you, everybody, for attending. We had, looks like 14 concurrent viewers, 15. Had 7 likes. Be sure to hit that like button, and we will call it a night for Dale's portion of the program.
Okay, thank you. Good night, everyone.
Have a good night, and be sure to catch all the live viewing that's going on until midnight.
Okay, I'm going to leave, Jeff.
Yep. We're both out of here.